Welcome to Walk About the Galaxy, the astronomy podcast for everyone, where the science is universal, the opinions are personal, and the trivia is elemental. We are Strange, Charm, and Top the Astroquarks, also known as Josh Caldwell,
Patty Dove,
and Jim Cooney,
coming to you from physically but not socially distant locations near the University of Central Florida. Remember to check out our website to see how to get our snazzy shirts and subscribe to us on all platforms, including YouTube. In this episode on YouTube, the Astroquarks will be played by Patrick Stewart,
Osiris Rex,
and Dom DeLuise.
Nice. Our stumpers today are vacation destinational.
That sounds lovely.
Yeah. I think these are, I've been sometimes kind of hard on you guys with the stumpers.
Yeah.
And so taking it easy, giving you a break.
Sending us to distant places alone for years.
Yeah, it was always like horrible. It was always like buried.
How would you like
in
to die?
Quicksand on a beach with a rising tide, or covered with honey and dropped into a giant ant nest. So they're going to go the other direction. Two nice options for you.
Okay.
Addie, Amazon rainforest, or Australian outback.
Are either of them on fire when I'm going there?
You can choose your season within one calendar year.
Okay.
And if you happen to choose unluckily enough,
they
might be on fire.
Yeah. I guess the outback is less likely to be on fire, but I'm going to choose Amazon.
Okay.
I like the idea of going to a rainforest. I also, when I was a kid, loved playing Amazon Trail. And so I've always dreamed of like, what? It was a game kind of like Oregon Trail, except not. But it's a game where you're like going down the Amazon and you're trying to get to the end. And there's like, you stop and trade, and then you can fish for things, and you have to take pictures of plants. No, it's a computer game. Like Oregon Trail.
It's like this another one of these things you made up, like Duck, Duck, Goose.
Like Duck, Duck, Goose. Do you know Oregon Trail, Josh?
No.
He must.
I've heard of the real Oregon Trail when I took history in third grade or whatever.
No.
Yeah.
No.
It's not.
You've never had dysentery?
I've never had dysentery. Happy to report that.
You've missed out on seminal aspects of the human experience.
Welcome to Walk About the Galaxy, where the hosts are dysentery free.
You've never had to ford a river?
I've never had to ford a river, but I have waded in a creek.
Oh, you have to do that sometimes too. So.
All right. Well, would you be fording the Amazon if you went to the Amazon rainforest?
No, that was Oregon Trail. You never had to ford the Amazon.
Okay. Well, my brother spent several weeks in the Amazon making the movie Anaconda.
Ooh.
Some years ago.
Did he see a real anaconda?
I don't know for sure. He saw a lot of interesting wildlife, though, including in the treehouse hotel.
He must have seen a real anaconda, because I'm pretty sure that was a
treehouse hotel.
So many things going on. So yes, they stayed in a treehouse hotel that was frequented by lots of frogs, I think was an issue.
That's so cool.
What did you say, Jim?
Anaconda was a documentary.
That's what I was under the impression it was a documentary. So I thought he'd definitely have seen real anacondas.
Yeah.
The documentary with Jon Voight and J-Lo.
Yeah.
Uh-huh.
Yes. Yeah. It was right before J-Lo exploded into superstardom. I visited on the set
into pieces. So
I visited the set of that movie, not the one in the Amazon rainforest, but the recreation of it at the LA Arboretum in Monrovia, California.
Ooh.
And J-Lo was there walking around, and that was just this random actor who happened to be in this movie. With Owen Wilson also, as before he became a big name. Anyway, we digress. Jim, your choices are the Florida Keys or the Pacific Northwest. I was thinking fishing locales. I may have chosen terribly. I know you're more sort of a freshwater person, but
yeah, I mean, I don't necessarily. If it was a fishing trip, it would be the Keys. But I think I would rather go to the Pacific Northwest, because I've never been there. Well, I mean, I've been to California, but I've never been to Washington or Oregon, and I think it's beautiful up there.
Yeah.
And in fact, we've toyed with it. If I was going to move someplace in the U.S., that's probably the place I'd move. We've looked at some places in Oregon and stuff like that.
Okay.
Mm.
I'm kind of
the Keys just
Yeah.
do not. I have lived in Florida for 25 years. I've never been to the Keys, and I have no
What?
desire to go to the Keys for some
You've
reason.
never been to the Keys?
I've
Are you
never been to
aware
the
of
Keys.
are you aware of their fantasy festival or something? I can't remember what it's called because I've
Fantasy
never been to it, but they have
Sounds fun.
they have naked people cavorting around certain times of year.
True.
Well, I enjoy that.
Are you thinking of Gasparilla? Josh, there's that too, but that's not in the
No.
Keys.
No, I wasn't. I don't know anything about it.
Okay.
I'm kind of thinking though that I prefer the stumpers that make you miserable instead of the ones that make you happy.
Oh, boo.
They're more fun than this one. This one was too laid
I like
back.
this one better.
Yeah. Okay. Well, today we'll talk about things that don't have anything to do with those places. Swarms of black holes. And we'll get updates from the many missions to the moon and Mars. But first, this episode of Walkabout the Galaxy is brought to you by Heavy Water. Not just a great song from Jethro Tull's underrated Rock Island album, Heavy Water is the perfect solution for those looking to master swimming without fear of sinking. Its density of 11% greater than your run-of-the-mill light water, thanks to not one but 2 extra neutrons, will have you feel like you're floating on air, except you'll be floating on water. Naturally occurring and non-radioactive heavy water is also great for detecting neutrinos and enhancing the output of your nuclear reactor. So, whether you want to be able to just float in a pool, moderate fissile neutrons, or untangle the mysteries of the cosmos from a shower of neutrinos, try heavy water. Note, prolonged intake of heavy water may lead to sterility, cytotoxic poisoning, and death. Heavy water, what's the worst that could happen?
I have a question for our sponsor this episode, Heavy Water. Do you always have both of your hydrogens heavy, or if just one of the two is heavy, do you call yourself Heavy Water?
If you're HDO instead of D2O, you're a form of heavy water if you're HDO. Yeah. But D2O, which is deuterium oxide, is what's my extensive research and conversations with the sponsor were indicated as heavy water. But yes, you can take your normal light water, H2O, and you can replace one of the hydrogens with deuterium and have HDO, or you could replace both of them with deuterium and have D2O.
Yeah, and for
is HDO one of those streaming services?
Are you talking about? Of course, deuterium is just an isotope of hydrogen. It just has one extra neutron. Instead of 0 neutrons, it has 1 neutron, right? Usually hydrogen is the simplest thing in the universe, element-wise, just 1 proton surrounded by 1 electron. But you can get it to live for a little while with 1 neutron in there as well. And that's deuterium.
Yes.
Also, what if you had 1 regular hydrogen and a tritium? Is that heavy water?
Oh, you have so many deep questions.
That is radioactive, and I declined their offer to be included in the sponsor message because of that.
Okay.
So that's why. But I was surprised. I did have some concerns. As you noticed, we were required to include a health disclaimer for heavy water.
Yeah. Yeah.
Because while it's non-radioactive and it's naturally occurring, although in minute amounts, but there's some heavy water in your body right now.
Is that why I weighed a little bit more when I got on the scale earlier? Was it heavy water?
Yeah. It's we're mostly water, and a fraction of the water in our bodies has a deuterium in there. But if you replaced all the water with deuterium, very bad things happen.
Would be unpleasant.
Which is interesting because the reason that deuterium is called an isotope instead of a different element than hydrogen is because chemically it's supposed to be the same, right?
Yeah.
There's just that 1 electron, so that's still going to be interacting with other elements and molecules the same way. But it turns out that extra neutron in hydrogen in the nucleus of heavy water screws up the normal hydrogen bonds that are necessary at the atomic scale machinery of life. There's only some bacteria that can sort of manage if they're in a laboratory setting, replace all the normal water with heavy water. Of course, not something that can happen. It's like you'd have to, it's only something you can do in a mad scientist
My fridge
laboratory.
turned my water into heavy water.
Right. Yeah.
To be clear, just because the sponsor just texted me and let me know, deuterium is radioactive. It's just its half-life is something like 12 years. So you have a lot of it. Yeah, deuterium is not stable. It's radioactive, but it's much longer half-life than tritium, which of course very short half-life, which makes it more dangerous in the short term.
I'm gonna have to check my correspondences with the sponsor.
Yeah, they didn't tell you all their disclaimers.
They specifically told me they were non-radioactive.
Yeah, well, that's weird. That's weird. The cigarette industry tried to tell you for years.
Yeah. HDO, my sources would call semi-heavy water.
Oh, okay. I like that.
Yeah.
And the tritium version would be called tritiated water.
Tritiated. All right, I'm definitely playing that next time I play Scrabble. Let's see if I get in trouble or not.
Tritiated.
On you. Tritiated water. Yeah. Yeah. Okay.
Do you think if we bottled stuff and said HDO or like heavy water, you could sell that as like a sports drink? I bet you could.
Yeah. Yeah, you just put on the thing, it's whatever percent heavy water that is like the naturally occurring amount, and sell it for an extra high
patent that whole thing. There you go.
Yeah.
All right. Some enterprising person out there is going to take this idea, and
we got our $1 million idea.
We just want 10%.
There you go.
Yeah.
There you go. It's all the rest is yours. You're welcome.
Yes. What was the final line of the sponsor message?
What's the worst that could happen?
That's my motto.
I have no idea. Traveler's insurance.
This was a very surprising to me.
What's the worst that could happen? Gatorade.
That's actually surprisingly close. Dr. Pepper.
That's not their current thing, is it?
There's a YouTube video from 2018 with Jesse Eisenberg. Is that the guy's name?
Okay. Yeah.
For Dr. Pepper, called "What's the Worst That Could Happen?"
Okay.
And actually, it turns out pretty bad. Like the whole grocery shelf thing collapsed on him, and the paramedics took all his clothes off and paraded him around outside naked for some reason.
That sounds terrible.
Anyway, shortly, 60 more Starlink satellites are going to launch from just outside my window here. And
do you think they'll land the booster this time? Last launch, they didn't land the booster.
They had a failure to land for the first time in a while, ending a long streak of successful recoveries at their first stage.
Yeah.
Yeah. I believe they
not only did they trash space, they trashed the ocean too.
Yeah. I believe they did track down the root cause of that problem.
Yeah.
As listeners of the show know, we're also awaiting another launch of the suborbital variety for our experiment, the Collisions into Dust experiment on Virgin Galactic's Spaceship 2. That
any day now.
Now they've announced is probably going to be targeted for the May timeframe. And so we're looking forward to that one. Perseverance is healthy and talking to us on Mars, and it's taken some amazing pictures, got some incredible instruments and very nice cameras. And one of the nice things about Mars being close by, first, it's like not so hard to get there, but also it's not so hard for photons in the form of radio photons to get back to us from Mars. So we actually get really good data rates from our Mars missions compared to the relative trickle that we get from something like New Horizons, flying by Pluto, where it's, 1 week of intensive observations of Pluto took months literally to be downloaded from there.
So does Percy contact us directly? I know some of those things that land on places like contact orbiting things around Mars, which then contact us. Is that how this is working?
Yeah, so they use MRO and MAVEN,
which is the Mars
Reconnaissance Orbiter, yeah. And then MAVEN as relay. Maybe Odyssey can still be a relay, I don't remember.
Is that primarily because the radio transmitter on Percy, they didn't want to get a big beefy one, so they just got a weak one that can talk to the.
Yeah.
I learned something new today. Fantastic.
We did talk about that when we had Dr. David Brain on.
Really?
Because they had
I was here for that episode.
I know.
You were in a box right there on our screen.
And now that you're saying this, I guess I'm vaguely remembering that. I guess I didn't learn something new. I relearned something new from
Yay. Sometimes it takes a few times to learn a thing.
Yeah.
Everybody should re-listen to these podcast episodes 3 or 4
Yeah.
times, probably.
Exactly.
So it's returned some amazing things. And one of course, some of the most exciting of those images coming back were the videos and images that were taken during the landing stage, which we did not get for the Curiosity landing 10 years ago. Same general sky crane approach, but this time the sky crane was taking video looking down at the surface of Mars as it was suspending the rover from cables, and you could see the dust blasting off the surface, and the rover was looking up at the sky crane spacecraft during that same time as well. And then you could see the sky crane fly off after it dropped Percy off. Super cool sci-fi level stuff going on.
Yeah.
There,
that was
which
a really awesome thing to see. Yeah, it was cool. Yeah. What happened to the sky crane spacecraft? Where does that go?
A few hundred meters away, and it crashed. It just sort of flies on. It no longer has the weight of Percy on it. And so once it cuts those cords, it's got a lot less weight. It just goes flying off until its rockets are done, which was pretty quickly. So it doesn't go, it's hundreds of meters away, I believe. And in fact, we have images from those same orbiting spacecraft that are relaying the data, have seen the crash sky crane, the back shell, the thing that had the parachute assembly attached to it for the main parachute. And of course, there's a fun story about the parachute too.
Yeah, the JPL likes to do a lot of little Easter eggs in their missions. So on Curiosity, I think it was at the tread, there was a little Morse code, basically Morse code. Braille maybe?
Braille?
I don't know. Yeah, I think it was Braille in the pattern in the wheel tread was spelled out JPL, I think. But this one is there's a couple of things, but the big one is that the parachutes, if you look at them, they have like sort of orange and white blocks, and it was in you're like, oh, that's a weird pattern. It's not very symmetric. And it's spelled out, what is it?
Dare mighty things.
Yeah, which is JPL's very
what was the
modest
type of code that they used for that?
I think it's Morse code, where like certain numbers of things,
white is a dash and orange is a dot, or vice versa, or something like that.
But I think it was more complicated than that. It was something where like they were kind of daring people to sleuth it out, right? And it didn't take long. It took a few hours or something for the internet sleuths to figure out what it said. But it was a non-obvious thing.
They can't be daring them to figure it out, because they have to figure it out in order to read the word dare. So
Sure.
Anyway,
it was and then on the outside, on the outer rim, it had like the coordinates for JPL, I think.
Okay. Yeah. Maybe Matthew McConaughey will see that and go there and go to a black hole.
Matthew McConaughey will?
In Interstellar, there's this ridiculous thing about him getting coordinates, and then he goes there, and that's how he ends up on the ship, which is stupid.
I asked my class about that movie the other day, and everybody said it was the best.
Yeah, that talk about, I guess you got a good group of I don't want to use salty language, but your students really wanted to make sure that they knew they agreed with you.
Right.
It was just binary. It was binary.
Binary?
Binary. Yeah. How do I turn D into, how do I make D
zeros
out of binary?
So like 1 is A, 2 is B, 3 is C, 4 is D, stuff like that.
Oh, okay.
There's up there, you can look, if you Google Perseverance parachutes, you'll find the code.
Okay. Well,
anyway.
I'm gonna let you know what our trivia is now, because it sort of ties to our sponsor a little bit before we head off into the deep realms of space. and talk about black holes. So our sponsor, Heavy Water, whose radioactivity is now some sort of point of contention, boasted of its higher density than light water, enough to make it so that even I could float in it. Human bodies are about roughly within a few percent, typically about the same density as water, but it put me in a pool, forget about it. I have to like inhale to some great extent, and then I will float vertically with the top of my head barely.
What about in the ocean?
Of the water. Salt is good, but heavy water would be more fun.
Sounds a little bit like a humble brag there, saying he's ripped, right? Because if you're very muscular,
I'm not actually. Despite what we said in an earlier episode, I'm not ripped. In
any event, you're pretty good shape. You're pretty good shape. That's pretty good.
In any event, our trivia today has to do with densities.
Okay.
And just elemental densities. Which of the following elements has the highest density? And can you estimate or know what that density is? So I'm going to give you 6 elements.
Okay.
Plutonium, which is radioactive. Platinum. Osmium, not just a Spider-Man character. Iridium. Uranium, also radioactive. Or tungsten. Which of those has the highest density, and what is that density relative to water? So we'll come back to that after we talk about, guess what? It's either Mars or black holes lately. So let's talk black holes.
Black holes.
Yeah, this this article we'll talk about here, it's about black holes, but it's not really. Black holes aren't really the main focus of this. Even though that's what the headlines are all like, because everybody loves black holes and clicks on things when you have black holes in the headlines. But this was a deeper dive into a globular cluster. We don't get to talk about globular clusters too often, but they're pretty awesome.
I like them.
Agreed?
They look cool.
Yeah, I mean, if your stumper was globular cluster or open cluster, what would you go for?
Ooh.
Josh didn't get a stumper because he never does. So Josh, your stumper today is globular cluster or open cluster?
Do I have to go there? Are my friends still going to be here when I get back? So the questions you guys asked me.
You don't have to go there.
Globular cluster for sure then, yes.
Okay,
yeah.
Great. Yeah, they're very cool because they not only they look really neat in telescopic images. Globular clusters don't tend to be or aren't visible with the naked eye, but in telescopic images, globular clusters are awesome. They're collections of typically a few 100,000 stars in a fairly tight sphere, and they're part of our galaxy, or at least many of them are part of our galaxy. There are, 120-ish known globular clusters associated with our galaxy. They tend to not live in the disk, the flattened pancake part of the galaxy, but they live in what's called the halo of the galaxy, which is just kind of the spherical component of our galaxy. And they're
sort of like in a spherical centered on the central sort of hub or axle of the Milky Way. So they're typically closer towards the center of the galaxy than we are in our spiral arm. Is that right?
Right. They can be. I mean, they can be farther out, but yeah, they tend to be. The primary portion of the halo is considerably closer to the center of the Milky Way than we are. But yeah, and the cool thing, I think the coolest thing about them is their age. Yeah, the population of stars in these things, and Josh can tell you whether it's population 0, 1, 2, 3, 5, or 8. They're old in any event, right? These are some of the oldest stars in the universe that we're aware of. They're the oldest stars in our galaxy, and they're all clumped together here. And they're all of very, very similar ages, or almost all of very, very similar ages. And they're kind of mysterious. We still don't have a good explanation for how they came to be, why they're there, and all this other business, which is kind of cool. But they're neat. They're neat places to study all kinds of interesting things. To study things like old stars, of course, but also to study things like stellar collisions, because the density of stars in those things is very, very high compared to, in the typical in our neighborhood, for example, of the Milky Way. So this recent study was looking kind of at the center of one of these things because of course, at the centers of big galaxies, or typical galaxies, which have hundreds of billions of stars, we find supermassive black holes. So a good question to ask is, at the centers of these globular clusters, which look a lot like small elliptical galaxies, do those things have black holes in the centers of them?
And in particular, they're like hunting for the elusive intermediate mass black hole.
Right. Because in our galaxy, which is hundreds of billions of stars, we have a supermassive black hole. Maybe in these smaller conglomerations, right, that have only hundreds of thousands of stars, maybe there would be black holes that were correspondingly, or not exactly correspondingly, but smaller, right? Maybe you'd have a black hole that was 10,000 times the mass of the sun, or 5,000 times the mass of the sun, or something. These are the kinds of black holes that we've not seen that size before. We see ones that are 10 or 20 times the size of the sun. We see millions or billions of times, but not the in between. And we've mentioned those before. But that would be super fun to find. So we're kind of hunting one of those.
There was in a recent episode not too long ago, we talked about a lot of excitement because they think they found one that was about 100, which was, significantly larger than the so-called stellar mass black holes that are produced through the normal sort of life cycle of stars, and then maybe a couple of them merging or something like that.
Yeah. So the center of a globular cluster would be a great place to look for one of these things. And specifically, there were some folks using the Hubble Space Telescope, looking at the globular cluster NGC 6397, another very
that's a good one
thing. Yeah. And what they found was actually something fairly interesting. They did find that there was a fairly dense central collection of mass in there, and they thought for a while that they might have found one of these elusive, middle mass black holes, and we're very excited. It turns out it's not that. It turns out that one of the cool things about these globular clusters is that you can make out a lot of the stars in them. Right, they're near the Milky, or in the Milky Way, so they're not very far away. So you can see individual stars and look at their orbits around the central part of that globular cluster and figure out kind of what's in there, not only what its mass is, but how that mass is distributed, roughly speaking. And what they found is it's not a very point-like object, which is what we'd expect, if it was a single large black hole. What they found is this kind of, it's a very massive thing, but it's spread out over a much larger area. And so that the most likely scenario based on that data combined with our understanding of how stars evolve is it's like a swarm of stellar mass black holes.
Like a few dozen or something, perhaps.
Yeah.
Of these things with a total mass of hundreds of times the mass of the sun, but not concentrated in this thing. And it's crazy difficult to do what they did, because it's not like they got a picture of these things at the center of the black hole. What they have is data from the Hubble Space Telescope and the European Gaia astrometric observatory, giving very, very, very precise measurements of the positions and motions of the stars in the globular cluster, so they can see the motions of these stars, and from that deduce the gravitational field that those stars are moving around in.
Yeah.
Because they're, and then they tried lots of different models, like said, okay, let's put a 500 stellar mass, intermediate mass black hole in the center there and run some simulations and compare that to the observations that we see and see how that compares. It's very complicated data reduction process and very sophisticated computer modeling to sort of arrive at this conclusion.
The thing that impressed me, everything about these kinds of observations is ridiculously impressive, but to actually be able to measure, because what they were, like Jeff said, what they're doing is they're constructing a three-dimensional version of the motions, constructing the velocities of these things in 3 dimensions. And that's 2 dimensions is pretty easy, meaning you can figure out if a star is moving towards or away from you pretty easily and with a pretty high accuracy by looking at its Doppler shift, right? Because light is Doppler shifted. If the source of the light is moving towards or away from you, it shifts to the red or the blue, red shifts and blue shifts. That's pretty easy, but figuring out how it's moving in that other spatial dimension across your line of sight is very difficult.
And that's the only part that they used. Like these weren't spectral measurements. They don't have the line of sight velocities of these stars. They only have these really, really difficult measurements of just what you were describing. And then they use statistical arguments to say, well, if I see a whole bunch of left-right motions that are this big, and then looking at the overall distribution of stars and this thing on the sky, what is the most likely actual distribution of the velocities of these stars? There's something like 100,000 or so stars, you said, in these globular clusters. They analyzed the motions of about 9,000 of these stars because they had to like throw a bunch out because they're unusual in some way or another to come up with sort of this statistically good sample. Anyway, it's an impressive,
crazy impressive. Yeah, these people are smart.
And
they
so
found
one of the exciting things, though, is that if they're all this like swarm, and these things are buzzing around in a very tight, I say buzzing, they're interacting with each other gravitationally in a fairly small region of space, less than a light year across, having perhaps dozens of black holes interacting. Aren't those things going to run into each other?
Yeah, you'd think eventually. And they're at least close enough in interacting that they're going to be a non-trivial source of like gravitational waves. We might be able to see at some point as they accelerate each other, and big massive things accelerating produce black holes.
So the signals that we're already seeing from LIGO, many of which we don't know in direction, like where in space they're coming from, although I guess we do know that they're quite distant for the most part. They're coming from other galaxies.
Yeah.
But they could be coming from situations like this globular cluster in other galaxies.
Oh, absolutely. Yeah. I would imagine for sure. That's
so
if you're going to have collisions between black holes, this is a great place to do it. And it's kind of a cool thing as well. I mean, why are there just a bunch of black holes in there, right? I mean, you get this really cool separation that the kind of heavy things do in some sense fall to the middle of these things, these complicated gravitational interactions which over long periods of time bring these very massive black holes, because of course black holes are the end result of the very most massive stars, and so they tend to end up in the middle of these things. Very cool process.
Well, I mean, it's interesting you mentioned like the population of the stars. These are old stars. Typically the globular cluster stars are old, so they'd be like population 2 stars. But they're stars that formed, on the order of like 10 billion years ago instead of 4 or 5 billion years ago.
Yeah.
The stars that produce black holes burn out very quickly. They're massive stars, so they go through their tank of gas in a hurry compared to a relative, economy gas sipper like the sun, which takes 10 billion years to run through its tank. So that means that those black holes, they're stellar black holes, became black holes many billions of years ago. Inside this globular cluster in this tiny region of space. Is there anything we can learn from the fact that they haven't yet all collided with each other? Like we frequently try to dispel this misconception that, it's a strong gravity, so it like sucks things in.
Yeah.
The stars are moving around each other. The fact it's a star or a black hole doesn't make any difference. But when you have multiple objects interacting, as we said many times, the dynamics gets very, very complicated. And in those multi-particle interactions, you can have things end up on collision courses, and then their gravitation, the strong gravitational field can cause dissipation of energy, which is how you end up getting these things colliding in the first place. So is there information in the fact, is it surprising at all? I didn't see anything in the paper that said, how did these 50 or 60 black holes survive in this tiny space for 10 billion years without running into each other already?
Well, I'll admit I don't know the answer, but my suspicion is that so I don't know the time scale on which these things. I don't think all of the black holes would have formed in that central region. So I think there's a process of getting the heaviest things towards the center of this, and I don't know what the time scale for that process is. I tend to doubt that those black holes have all been buzzing around that small area for the entire 10 billion years that the globular cluster has been around.
Okay.
But having said that, I don't know that that's the answer. But
okay,
it's also true that the process by which these kind of black holes spiral in toward each other and eventually collide, the amount of energy that is lost through gravitational waves is fairly small until they get pretty darn close. And so
right. So there's not a lot of dissipation in the system. There's not a lot of
right. I mean, it's there. I mean, anytime you have, I mean, if you're producing gravitational waves of any kind, you're losing energy and therefore kind of spiraling in. But that process is weak and slow until you get really close.
Really
and then
close.
it goes berserk. Yeah.
Right. And they're so small. The event. Well, how big's the event horizon for a stellar mass black hole?
Very small, only a few kilometers, 3-4 kilometers,
Right.
something like that. It's very small.
So even though these are like within a light year of of space,
yeah,
it's very, very empty still. And
Yep.
they're
Yeah,
very, very,
exactly.
very widely spaced from each other. Okay,
Yep.
thanks. Yeah. Well, before we get to your density solutions, we'll check in. We talked about the Mars Perseverance rover, and we've got some cool pictures coming down. And a few months ago, we had the Chinese Chang'e 5
Yep.
lunar sample return came back. One of the missions to Mars is a Chinese rover that's in orbit and is going to be landing a little bit later this year. But they've had a successful lunar mission, and their samples have been returned to the Earth, and they're showing off some of those lunar rocks. How much did they get back?
It landed in December. I think we talked a little bit maybe about that. It landed in the, I don't know, remote part of the country.
Remote. Aren't all parts of the moon remote?
No, the one that
back
landed
on
on Earth.
Earth.
When it landed on Earth.
Okay, sorry. Yeah, I got you.
It did also collect a remote sample from,
Collected stuff
from the moon.
Like a remote part of the moon.
real
What is
wasteland.
this? Away from
It's
the
not a-
city.
Yeah.
Not a nice neighborhood on the moon. They went to
Okay.
real. It's like,
Well, the crazy part about that whole mission, right, is we talked about this a little bit, is like Perseverance took 7 months to get to Mars. It's going to be there for a while, and we're not going to get those samples back for years because we have to send something else to bring it back. But like the missions to the moon can be super fast. And so the Chang'e mission returned samples back in December. And they've just recently released some photos of some of those samples. And I guess there's like a little display thing that they're going to be putting on in some places. And they have talked about sharing some of the samples now with other countries. So I'm not sure like where that stands, but because one of the big things is we like to, when we get samples back, share them between countries for different scientists who do different types of analysis on things. I think they got back something like a little over 3 pounds, so 1,700 grams of lunar samples,
which is a
pretty cool.
non-trivial amount from
Yeah.
a part of the moon that we haven't gotten samples back from before.
Exactly. Yeah, it was from Oceanus Procularum.
So this is a notably different environment than the Apollo astronauts grabbed stuff from?
Yeah, I mean, it's still
Mare.
like sort of equatorial, sort of mare, because it's one of the oceans, right? I think they're saying that they see some interesting glasses, which we sometimes see in lunar rocks, and some dark material, some light material.
Technical
Right.
terms, yeah.
Yeah, exactly. But some really fine, and they have some nice fine dust in there, some basaltic glasses, things like that.
So glasses happen when certain minerals are superheated and then cool in a certain way.
Yeah. So a lot of the basaltic glasses on the moon may have come from like early volcanism, but some of them come from impacts.
Yeah.
Pretty cool. Have some more lunar samples. It's interesting too, because just recently, like in this last year, there were a new set of samples that NASA released from the original Apollo missions that had been kept and hadn't been opened since the Apollo days. But there was a proposal call, and a bunch of folks put in proposals to do completely new, unique analyses on lunar samples from the Apollo missions, but that have just been sort of kept in like dry nitrogen and stuff like that the whole time. And they opened them for the first time.
That was done deliberately 50 years ago or whatever, to say,
Yeah.
you know what, it's quite likely that 50 years from now we're going to have some better tools and equipment to figure things out from this. So let's just take this pile, set it aside, and wait several decades, and then we'll maybe be able to do better things with it, which is kind of impressive.
Same
restraint.
reason that I'm going to get frozen when I'm close to death.
There you go.
There you go.
There you go.
They
You just have to know when you're close to death.
That's true. That's the trick.
Yeah. Well, I might just do it next week. I'm not sure.
What's the density of lunar dirt, Addie?
Probably around 3.5.
What?
3.5 grams per cubic centimeter, about 3.5 times the density of water.
Right.
Somewhere in that ballpark, 2.5, 3, somewhere in that.
Yeah, that's true.
That
Probably
ballpark. Rocks are sort of in that 2.5, 3.5 range. And then when you start mixing metals in, they get denser. So your choices for
what a great segue.
There you go. Yeah. Your choices for most dense element were plutonium, platinum, osmium, iridium, uranium, or tungsten.
So I actually know the answer to this, so I'll let.
Oh no, go then. You can go. It's fine.
No, I'll let Eddie go. I don't know the answer to the second part, which is what is the actual density.
What is the density?
I do know the densest element, so I'll let Eddie, or I guess that maybe she knows as well, but
I don't think I know.
I know, so
I did not know.
Iridium. I don't think it's iridium, but I like iridium, so I'm gonna guess.
What do you say, Jim?
It's osmium.
It is osmium, but
name.
iridium is second by a hair. So well done, Addie. And I almost left osmium off and just said which is the densest of these.
Ooh, yeah, that would have got me. I think.
What is the density of either of those? They're almost identically, they're almost the same, but osmium is slightly more dense.
Yeah, I don't know. Eddie, you gotta.
You have to go first this time, Mr. I know.
Oh yeah, I really don't know. I'm gonna say it's 12.
12 times the density of water.
Yeah.
Addie, what do you say?
I'm gonna go with 11.
You're both way off. 22.6 for osmium.
Wow, I should have guessed 22. That's my other lucky number.
Both iridium and osmium are in the platinum group. Platinum is almost as dense as those two. They're adjacent to each other, 76, 77, and 78 protons in their nuclei. Plutonium, nasty radioactive plutonium, only 13.7 times.
It doesn't appreciate being referred to as nasty, Josh.
Yeah, well, come and get me, plutonium. No, please don't. Please don't.
No, we like plutonium for spacecraft.
My sources, Jim, by the way, speaking of plutonium and radioactivity, say deuterium is one of 2 stable isotopes of hydrogen. And that heavy water is non-radioactive. So we've embarrassed ourselves by not
You're
knowing.
Just Googling different results is what's happening right now behind the scenes.
Well, I will yield. I don't know. We'll
You said the sponsor texted you. You said the sponsor texted you, Jim.
Maybe the sponsor is like was trying to.
I think maybe it was the sponsor's little kid sister got a hold of the sponsor's phone and was texting you some.
Okay, I've just received another text message from the sponsor, and he says that Josh is right.
Oh, okay.
Stable. Wow. Man, there's some kind of malfeasance going on.
Whirlwind of emotions.
Yeah.
No.
Well, while it may have felt like the time for 2 astroquarks to get their act together, it was just another episode of Walk About the Galaxy. Write us a review in code on the underside of a NASA probe parachute, and then just let that go viral. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walk About the Galaxy, where you can see most of our episodes, some of our bloopers, and all of our music videos. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
at walk_the_galaxy.
And ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Drusick. Merci à notre public à Québec et partout dans le monde. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm an idiot.
We're the Astroquarks, signing off until the next episode of Walk About the Galaxy.